Flack math! Give me some math and I'll give you some flack. Flack math!
Okay, so let's just review real quick. Number one, ratio box. If you write a ratio box with the total, I think it was good guys, bad guys. Let's do number two. Sorry, real quick. Blue marbles to green marbles, so 17 to 5, and then you got a total, 22. And then it says 110 marbles, not 110 blue or green, just 110 marbles, and it asks for how many are blue. So this is your ratio. You can fish method, 110 times 17 divided by 22, or notice, hey, that's times 5, so this times 5 is 85. Okay. And then the other two that we did were just translating those and solving. So check your solutions on that if you want to get more detail, but we're going to move on to number 5. Oh yeah, this was the equation that I'm erasing for number 4. Okay, number 5. Use 2 unit multipliers to convert 40 square inches to square meters. Square inches to square meters. Okay, so here's the deal. You're going from US customary to metric. So you have to cross this little river over here. To cross this river, you have to cross it here from inches to centimeters. So we're already at the inches town. So we have to cross the bridge to centimeters and then go to meters, okay? You could try to do this in your head, but it gets a little complicated. And what makes it even more complicated is the square conversions, okay? Area conversions, yes.
Well, it seems like whenever I do these, it's slightly off, but really close. It seems like
Okay.
the conversions chart that I use has the conversions rounded, maybe a slightly different way.
Yeah, so do you do, because you can convert from like feet to meters or things like that, or, but it's better to convert at 2.54. Do you use 2.54 or 2.5? Okay, well, let's see if we do it the same way you do, okay? So 40 inches, first step to unit multipliers is write the first unit as a fraction. So in most cases, you're just gonna write it over 1, right? First step done. There's only 2 steps to unit multipliers, and you're gonna repeat those as you go, and you're really just repeating step 2 as much as you need to, okay? So going from inches, we got to cross the bridge to centimeters. All right, so you have to choose a unit multiplier that will cancel the first label. So it'll cross cancel the first label and end up with where you want to go. We want to go to centimeters. We don't want to go to meters yet. You can't just skip a town. You have to go through that town at least. So we need an inches, and we want to get to centimeters. So, and there are 2.54 centimeters in 1 inch. This is the hardest unit multiplier to remember. You guys know that there's 12 inches in a foot. Hopefully most of you know that there's 5280 feet in a mile. You know that there's 100 centimeters in a meter. Those are the only ones that you really, and most of the time when we do a practice test, it's using the same conversions. But it might be going the other direction, going from square meters to square inches or something, okay? So in this case, look what happens. You're only canceling, this is inches times inches. So you're only canceling 1 of these inches. So you need 2 of these. Because you want to end up with not centimeters, but centimeter squared. So multiply by another unit multiplier. Okay? But we're not where we want to be. We want to be at meters, right? So let's get to meters by doing another unit multiplier. We need centimeters on the bottom because that's what we're trying to cancel. We want meters on top because that's where we're trying to go. And we need 2 of them because there's 2 centimeters. So how many centimeters are in a meter? 100. So 100 goes with centimeters and 1 goes with meter. 100 centimeters and 1 meter. Okay, now all we have to do is multiply across, multiply at the top, multiply the bottom. So you get 40 times 2.54 times 2.54 times 1 times 1 times meter times meter. So make sure that label's up there on top. Then 1 times 1 times 1 times 100 times 100. So this is what you end up with. You can leave your answer like that if you want. Or you can multiply it out on a calculator. So what'd you get when you multiplied it out on a calculator? Did you get the same as the solutions? Or you were slightly off?
A couple, like literally like 1 or 2 off.
Okay, well, let's look at it. So I'm going to go 40 times 2.54 times 2.54 equals blah, divided by 100 times 100 is 10,000, but we'll just do this the old way. So I got 0.0258-ish. So 0.0, what does it say? It doesn't say to round or anything like that. So,
That's what I got.
okay, cool. So you can leave your answer like this. This is actually a little bit more exact because then you'd have to round your other one. So you can leave it like that. And if you show all the steps to unit multipliers, I'm going to give you extra credit, okay? So if you're doing unit multipliers correctly, I'm going to give you extra credit because I want you to start doing these problems like this. Again, you could convert these in another way, but it gets confusing when you're dealing with square units. My tree's falling down. Okay. Number 6, let's keep moving. Draw a number line and graph x is less than or equal to -3. So all you need here is a line with a -3 on it. You're half done, okay? So now I want to know which side of the -3 to shade. So you have to decide 2 things, which side to shade and whether to fill in the dot or leave it open on -3. Are you going to fill it in or leave it open? Fill it in, because if you fill in something, that means you're including that something. You're including that -3. And this says shade. Which direction is this pointing? Left or right? Left. So we're going to shade left. So when the x is on this side, you can just read it left to right. Shade, the solutions are to the left of and on top of -3. Okay? If it was just less than, then that you'd be an open circle, so you're trying to protect that 3 from being included in your solution. So it's like a little force field that you want to keep away the shading. Okay? Good on number 6? All right, just 2 decisions. Which side to shade on and whether to fill it in or not. And another rule is if it takes more lead or ink to draw the symbol, it's going to take more lead or ink to graph it. Okay? All right, number 7. So this says, number 7 is, I'm just going to translate this. 2.03 of in math is multiply. 0.045. 2.03 of 0.045 is what number? Is what number? That's your variable. Okay, so let's do that math. Who's got that? What'd you get?
I got 0.0935.
All right, that sounds right. 0.0935. All we did was clean up that left side. If you want to follow the steps of the equations, you can. You're just cleaning up the left side separately, and then you already have n by itself. Yes.
Like we have to have 5 decimal places. We have 5 decimal places.
If we were to multiply it, what'd you say, 0.0935? Is that what you said? So if I were to multiply this out, blah, blah, blah. Well, we can just make sure here. Oh, 9135. Is that what you said, Elkin? Did I forget the one?
Yeah.
Yeah. Sorry about that. Okay, good. All right, number 8. So number 8 is just like number 6, except going the other way. So we need to write an inequality that describes this graph. Okay, so you can go backwards. So it's going to be x on the left side and it's going to be 2 on the other side, right? So which side are you shading? Are you shading to the left or to the right? Shading to the right, so point the arrow to the right. Now, are you filling it in or are you leaving it open? Well, it's filled in, so we put a line under it. Okay? I think it is. Yeah, it looks like it. So remember, if that's an open circle, don't put the line under it. Can you guys remember that? All right, good. All right, moving on to number 9. Can't reach as far in my mom's sweater.
Is that actually a mom's sweater?
Yeah,
Oh my god.
that's where I get all the good sweaters. No offense to her. She knows it. But
I
love
didn't
you,
realize how
Mom.
short it was.
What's that?
I didn't realize how short it was.
Yeah. That's what just adds to the ugly factor. Is like, I have no business wearing a sweater like this. It's very, yeah, momish. All right, so here's what this says. If f of x equals negative x squared plus 7, find f of negative 2. This is where a lot of students get confused. This does not say f times x and you have to solve for f type of thing. Don't do that, okay? This is just say, okay, the function of x is to square it, negate it, and add 7, okay? So whatever you plug in for x, you're going to square it, negate it, and add 7. Don't do anything on the left side. So here's what might be easier. Just forget about that and just plug in negative 2 right there. So you get negative 2. Now remember, when you plug in negative numbers, you need parentheses. If you don't use parentheses, you'll get this problem wrong. Okay, what's negative 2 parentheses squared? Because that's what you're going to do first. You don't apply the negative yet until after you square it. What's negative 2 parentheses squared?
4.
Positive 4. So that's a positive 4, but then you still have this lingering negative sign that you have to apply. So final answer, negative 4 plus positive 7 comes down to a 3. Okay? Is that what you guys got? All right. I saw you use your eraser. I didn't know. Like you got it wrong. It scared me for a second. Oh, okay. All right, number 10. We're going to simplify these guys. This is 10a. And 10b looks like this. 1 over negative 4 to the negative 3rd. Okay, so just like anything else, yes. Question, Nate? Okay. Just like anything else, we're going to deal with the exponent or the parentheses first. Okay. So the parentheses says this is negative 4. Keep it that way. Okay. And then what comes after parentheses? Exponents, right? So we're going to deal with that. We're not going to underline the negative because that's not what's being exponated. That's not a word. Okay. So we're going to deal with that first. What do you do with negative exponents? You put it, if it's upstairs, you put it downstairs. If it's downstairs, you put it upstairs, okay? So let's just do that. We're going to see what it looks like with literally doing that. So the only thing left upstairs here is my negative sign. So if I put all this downstairs, here's what it looks like. -4, parenthesis, to the positive third. And remember, when you change the position from upstairs to downstairs, or downstairs to upstairs, you negate the exponent. So if that exponent was negative on top, it's positive on the bottom. Okay? Remember, negative exponents have nothing to do with whether they're positive or negative. Okay, well, we just have this awkward negative sign on top. What else do we need up there? Yeah, if you're left with nothing, just put a 1 there. Okay, now we can figure this out. What's -4 to the third power? So -4 times -4 times -4. -64, right? Now, this isn't quite simplified because look what cancels. The negatives cancel, and you're just left with 1/64. Okay, so you deal with the negatives absolutely last. All right, well, let's deal with this negative exponent. What happens to this 4 to the negative third? Goes to the top. So now it's a 4 to the positive third on top with an awkward negative sign on the bottom. So what is that? What else do you need on the bottom? A 1. Okay. So what's 4 to the third?
64.
64 divided by -1. What's 64 divided by -1? -64. Okay. Lots of steps here. I know it doesn't seem like it. It seems like a nice little problem, but there's lots of things. You have to be careful. Go slow. Watch those negative signs. Those will creep up on you and mess you up if you're not careful. All right, number 11. Number 11 says simplify, factor if necessary. There's a nice little hint. Okay, so simplify, factor if necessary. X squared y. Okay, so if you do this, I will cry myself to sleep. Don't do that, okay? Because you can't cancel that. You could cancel it if it was just 8xy over 8xy, but it's not because it's 8xy plus something and then divided by. So remember, you can only cancel something if it's divided immediately after it's multiplied, okay? And only if it's multiplied. No, nothing else going on there, okay? So don't do that. Wish I had my undo button. That was annoying to get rid of. All right, so it says factor if necessary. So we can do that. So how do you factor 8xy plus 64x squared y? What goes into both of those? 8. What else goes into both of those? X. Anything else? And a y. So what are you left with? When you pull that out, when you divide it out, you're just left with 1 plus, let's see, 8x. Okay, now it's 8xy times something divided by 8xy. So guess what you can do now? Now you can cancel that and you're left with this. There is another way. If this is confusing to you, there's another way to do this. I'm going to say, or you could create 2 separate division problems. So if you're dividing this whole thing by 8xy, divide each term separately by 8xy. What's 8xy divided by itself? 1. And then what is 64? X squared y divided by 8. Well, 64 divided by 8 is 8. X squared divided by x is just an x. And the y's cancel. So you're left with 8x. Same thing. Okay, if that's easier for you, you can do it that way. Can you guys do it at least one of those ways? Okay, awesome. All right, moving on to 12. And if we don't get everything done today, that's okay. We'll review a little bit on Tuesday before we take the test, but I'm pretty sure we'll be close anyway.
Is it gonna
Okay.
be in class test?
Yeah, but you're gonna finish it at home, so just makes me feel better that you are at least taking a test here at school. So yeah. Okay, so here's number 12. It says underline, if you have the test in front of you, underline the word factor. Because it doesn't say just find the greatest common factor, it says factor. Okay, so here's what the problem is. 2m squared x cubed y to the 6th minus 4m cubed x cubed y squared plus 8m to the 4th x squared y cubed. Okay, so a lot of you on the last test found the greatest common factor, which is awesome. It's like 2m squared x squared y squared or something like that. And then you just moved on. But that's only part of it. So when you factor something, when you factor 21, it's not 3, right? It's 3 times 7. So when you factor out the greatest common factor, so the GCF is 2, and then you're looking for the smallest exponent of each letter. As opposed to what we talked about on Tuesday, you're looking for, when you're finding the least common multiple or the common denominator, you're looking for the biggest exponent of each letter. So what's the smallest exponent of x's? Looks like it's squared. And then y looks like it's also squared. And then m looks like that is also squared. Okay? So that's half credit right there. Good job. Well done. But what times this factoring something is what times what equals that. So this is just one of the factors. You have to give me the other factor. So what happens when you pull it out of there, when you divide this out of everything? What are you left with here? Let's see. The 2's cancel, right? The m squareds cancel. The x squared, ooh, that was ugly. I didn't put it in alphabetical order. That's going to bother me. X cubed over x squared. How many x's are you left with? Just an x, right? X cubed over x squared. 2 x's cancel, and you're left with 1 x on the top, okay? The y squareds, y to the 6th divided by y squared. What's y to the 6th divided by y squared? Y to the 4th. A common mistake is the 3rd. You're not dividing the exponents. You're subtracting the exponents when you divide. But don't say 8 divided by 2 is 6. So you're not subtracting the big numbers. You're only subtracting the little numbers, the exponents. So y to the 4th. All right, that one's done. And then you've got this divided by 2, x squared, y squared, m squared. 4 divided by 2 is 2. X cubed divided by x squared. Well, let's do the m's first. M cubed over m squared is m. X cubed over x squared is x. Y squared over y squared cancels, so you don't have any y's there. And then the last one, 8 divided by 2 is 4. M to the 4th by m squared is m squared. X squareds cancel. Y cubed over y squared is just y. Okay? So when you do that point, divide the big numbers by the greatest common factor. and then just subtract the exponents of the variables to get the variable parts of each of those terms, okay? A good way to check is to distribute. You should get this when you distribute. 2x squared y squared m squared times xy to the fourth. Add the exponents, you get x cubed, y to the 6, and then an m squared because there's no other m squareds, and then a 2. All right. If you guys can do that one, that's awesome. Yes. Uh-huh. Number 13, simplify, then answer with all variables in the numerator. So that second sentence, just ignore that for now. Let's just do this the way we like to do it. And I'm going to just do it my way, but you can do it however way gives you the most success. And if you haven't decided on a way yet, then I would suggest using my way. Because I'm usually successful in math. Sometimes I mess up. So here's the way I would suggest. You could use the quotient rule, which is, okay, a to the third divided by a to the negative fourth. You subtract, so a to the third minus negative fourth. Oh, you're subtracting a negative, so a to the third plus positive fourth is a to the positive seventh. Okay, a to the seventh. That's right, but see how that's potentially confusing. You're subtracting negatives and it's confusing. So what I'm going to do is I'm going to bring everybody upstairs. And we learned that we can do that as long as we change the exponent sign. Okay, so this c to the negative fourth downstairs becomes a c to the positive fourth upstairs. A b to the, what's the exponent for that b? What's the exponent for the b on the bottom? 1. So a b to the 1 on the bottom becomes b to the negative 1 on top. A to the negative 4 on bottom becomes a to the positive 4 on top. Now we can ignore that. And now we just add the exponents because everything's multiplication now. Everything's on the top. So now it's just adding the exponents. So let's start with our a's. A to the 3 plus 4 is 7. And then let's do our b's. B to the negative 5 and negative 1. That's negative 6. And then c's negative 1 and positive 4 is c to the third, okay? So that's my answer, and that's the right answer, but what does the question ask? Write the answer with all variables in the numerator, and we just did it. Now, sometimes it might say, write your answer with all positive exponents. Is this with all positive exponents? No, that negative 6. How do you make that negative 6 a positive exponent? Put it downstairs, right? So you could say this if it was asking for this, but it's not. This is the right answer. You just move that downstairs with the positive exponent, and there's another way to write that answer. Okay? Everyone okay with that? I would suggest doing it this way. It just makes it so much easier. Just don't forget to change the sign of the exponents when you bring them upstairs. Okay? All right, number 14. It says expand using the distributive property. All we're going to do is just multiply this stuff. A couple of you had some issues with this, so let's make sure you're paying attention here. Okay, this is the distributive property, so you can draw your cute little rainbows if you want, boom, boom. But these are a little bit difficult to do in your head, so I would suggest just writing them out, okay? So if you multiply these two fractions together, you just multiply the tops and multiply the bottoms, right? So I'm not gonna worry about cross-reducing, I'm just gonna do it. So this is m to the negative 2n cubed. I just squish them together. Right? That's all I did so far. I'm not worrying about anything else. Negative, I mean, you could deal with negative exponents if you want to, but I'm going to distribute first and then deal with that. So then if I squish all that together, I get m to the negative 2, 4am squared all over n times n to the negative third. I literally just squished it all together. I didn't do any math. Now I'm going to clean it up. Well, I'm going to clean this up the same way I cleaned up the problem above. So I'm going to bring all this upstairs and all this upstairs. So this becomes an n to the negative 1, m to the negative fourth. This becomes an n to the negative 1, n to the positive third. Now it's cleanup time. So add the exponents of the m's, m to the negative 6th, n to the positive 2, minus m, or I'm going to put a 4 out in front. Always put the numbers, the coefficients out front. Oh, we've got an a in there. Okay, so there's just an a by itself, so we're just going to leave that a alone. M to the negative 2 times m to the 2. What's m to the negative 2 times m to the 2? What's 2 plus negative 2? 0. What's anything to the 0 power? 1. So when you multiply by 1, nothing happens. So it cancels. So you can cancel those. If they have opposite exponents and they're multiplied together, you can cancel them. Okay, and then n to the negative 1 times n to the third is n squared. Okay, so recap, distribute. Don't worry about cleanup or simplify or anything like that. Distribute, squish it all together into two terms here. Clean up those terms the same way you did in number 13. And then write your answer. Now, what does the direction say? Let's see. Expand using, write the answer with all exponents positive. Are all exponents positive? No. We just have one guy breaking the law. That's the m over here. So we're going to make that negative 6 a positive 6. How do you do that? Put that downstairs of this term, not the whole expression, just that term. So then that becomes this. So here's my answer. All I did was just move that downstairs. If you have negative x, if they're asking for all positive exponents and you end up with positive exponents upstairs, move them downstairs. Okay? All right, number 15. We're going to simplify by adding like terms, but before we can do that, we need to simplify as much as we can, because we can't even recognize whether these are like terms yet. So in your notes, you can write simplify first. Before you combine like terms, you have to simplify the expression. So you probably have to add some exponents of variables that you're multiplying. You might have to deal with negative exponents. So let's do that. This is number 15. And here's what it says. Negative 4, a to the 0, a to the third, a to the negative 2, b to the fourth, plus 3a, b to the negative third, b to the eighth. Please correct me if I'm getting this wrong because my eyes are bad. B to the negative 1, plus 5, a to the fourth, a to the negative fourth, b to the fifth, b to the 0, and b to the negative 1. Okay, that's a lot of cleanup, but we can do that. We're going to clean up each of these three terms first and then see what happens. Well, luckily, they're all being multiplied. So what do you do with the exponents when you're multiplying variables? You add them, okay? Well, first of all, you can go through and do this. This is fun, liberating. Remember, anything to the 0 power cancels. If it cancels completely, you still have to put a 1, but most of the time you can just scratch them out. Okay, so I get negative 4a to the 3 plus negative 2. What's 3 plus negative 2? 1. So I'm not going to even put an exponent. Then b to the fourth. Right? There's no more b's to multiply. All right, so I'm going to put the 3 out front. A to the, any other a's? No. b to the -3 plus 5 plus -1 is 4. Then 5 to the a. Let's see, look, a to the 4th and a to the -4th. Yay, those cancel. See how I canceled those? And then a, b to the 5 plus -1 is 4. Look, they're all like terms. Yay. So now you're just adding the coefficients. -4 plus 3 is -1, plus +5 is +4, a, b to the 4th. Now, once you combine like terms, you don't touch the variables. Okay? But when you're multiplying, this is a confusing problem because a lot of you will say a cubed b to the 12th because you're used to adding the exponents. So do you see how that's incorrect? When you add like terms, you don't touch the variables. They're just there to tell you if they're like terms. You add the exponents only when you multiply variables together. We're not multiplying anything. We're adding. Okay? Number 16. Again, stop me if you're confused or anything's happening there. Number 16, I'm glad we get to do this again because we kind of forgot to record solving equations, but we're going to utilize all these steps to solving an equation. First step, simplify both sides separately. The first part of that step is to look for parentheses and get rid of them. Parentheses are the enemy of simplify. Okay, how do you get rid of the parentheses? You distribute whatever's on the outside of it. Okay, what is on the outside of this?
4.
I would say 4, but it's not. What is that?
It's a 1. There's a 1, isn't there?
Well, there's a
Just
1
the X.
there, but this is a -4. Okay, now make sure you do that because if you don't, it's going to be, so chicken scratch whenever you can. And see how there's nothing to chicken scratch here? So I'm going to do this. Look at this. Boom, boom. I chicken scratch. Now I'm going to distribute. I'm going to use a different color there. Okay, so now I'm going to distribute. So x plus -4 times x is -4x. -4 times -3 is +12. Now this time, I'm not distributing a number, I'm distributing a negative sign. Okay, so this is -8x plus -6. This is a tough problem. The subtracting a parenthesis or subtracting something times a parenthesis is difficult. So I would suggest chicken scratching to get rid of that confusion and then just distribute what you have left. I'm distributing not a 4, but a -4. I'm distributing not error, but a negative sign. Okay? All right, let's clean it up. Any like terms? Yes. X and -4x is -3x. And then we've got some like terms there. 8 and -6 is 2. Okay, so we're done with step 1. We combined like terms. We got rid of parentheses. Next step, eliminate or if variables on both sides. Yes. Which one's the smaller variable? Yeah, and remember variable term, not the constant term. But -8x is the smaller one. How do you get rid of -8x? Add 8x, add 8x. So you get 5x plus 12 equals 2. Eliminate constant from variable side. Which one's the constant on the variable side? There's a couple constants, but which one's a constant on the variable side? How do you get rid of plus 12? Subtract 12. 5x equals, what's 2 minus 12? -10. Last step, divide by variable's coefficient. Divide by 5, what do you get? So x equals -2. Good. All right, that was a crazy one. We're gonna do another one just like it. I think this one's a little bit easier actually. So this is number 17. Let me erase this. Wait,
How is 8 the smaller one?
Because it's negative. So negative 8x is smaller than negative 3x. But it doesn't matter which one you get rid of. If you would have gotten rid of the negative 3x, you would have ended up with a negative 5x over here and a positive 10 over there. You still would have gotten negative 2. But having a negative number multiplied by x makes it a little bit more confusing. So it doesn't matter which one you get rid of, but I would recommend getting rid of the smaller one. Okay? So that's not a deal breaker. If you get rid of the wrong one, there's not a wrong one to get rid of. Okay, number 17. And we'll probably just end with that and then do 18, 19, and 20 on Tuesday. And then I'll give you the test to at least start. Then you can finish it at home. So here's what 17 says. 2, parenthesis, 3 minus a minus parenthesis negative 2 times a minus 3 equals negative parenthesis 3a minus 2. Okay, so we're still going to do the first step. And I would say, if I were to add one more part to this, I would say chicken scratch first. Because chicken scratch makes it a little bit easier. So I'm going to go through and chicken scratch here. Whenever I see subtraction, make an addition, change the sign. Look at this, plus, positive, plus, negative. Okay, and what am I chicken scratching here? I'm just putting a negative there, and then I'm going to distribute that negative. Okay, and then this is a plus negative 2. Okay, now I'm going to distribute. 2 times 3 is 6. 2 times negative a is negative 2a, or plus negative 2a. Plus. Now I'm going to distribute that. What's 2 times a? 2a. What's 2 times negative 3? Negative 6, or plus negative 6. Now I'm distributing this negative sign. So that's a negative 3a. And negative times a negative is a positive 2. Okay, so chicken scratch first. I think that'll be more helpful for you. And then you know what you're distributing. Those subtraction signs will get you. Second part of step 1 is combine like terms. It looks like these guys cancel. Look at that. And then these guys cancel. 6 minus 6 cancel. So you're just left with 0 on this side. And then a negative 3a plus 2. If you would have combined those together, you would have had 0a, or just 0. And then 6 minus 6 is 0. All right? So now we don't even have variables on both sides, so we can skip step 2. Step 3 is get rid of constant on variable side. So to get rid of plus 2, you subtract 2. So you get negative 3a on this side and a negative 2 over here. 0 minus 2 is negative 2. And then how do you get rid of negative 3? Divide it because it's being multiplied. So a equals positive 2/3. Is that what the solution said? Because this always makes me nervous when there's a fraction, right? Let me make sure I copied the problem down right. Yeah, it looks right. Is that what you guys got? Anyone check their solutions? You don't have to. I mean, that's why we're here today. Okay, cool. So we will pick this up. We'll do 18, 19, and 20 at the beginning of class on Tuesday. And then I'll let you finish your test.
Flack math! Give me some math and I'll give you some flack. Flack math!